The Brandon Best Podcast. Episode 6. Healing Wounds with Ultrasound featuring Ian Robinson.
My guest today is Ian Robinson. Ian is a research assistant in the School of Biomedical Engineering, specifically on the optics and ultrasound wound healing team. He's here to talk to us today about some of the exciting new research being conducted within his team on healing wounds using ultrasound and discussing some of the other exciting applications that are being examined with ultrasound technology. I really enjoyed catching up with Ian. I met him about 2 years ago, and I've always, loved talking to him. He's a super smart guy, and I hope you guys enjoyed the episode. So I guess we can get started, but again, thanks for making the time. I appreciate it.
My pleasure.
So I was really intrigued for the stuff that you kind of messaged me when we were having our back and forth on LinkedIn about what you were working on. And it was very different from, I guess, back when I met you 2 years ago, what you wanted to work on, but still super interesting when you send me some of those links to look into. And I think I just wanted to start with, can we get like a cursory explanation of what exactly is ultrasound? Because I think we all kind of think, oh yeah, ultrasound's that thing with the gel and you just kind of rub it on a stomach and you see inside. But I feel like to understand your guys' research and the potential applications, there's a bit of a jump in knowledge as to, okay, like how does that even work with ultrasound?
Sure. Yeah. So a little bit of background on ultrasound. Imaging ultrasound is usually done in the megahertz range. So commonly you have devices that operate in the 2 or 3 megahertz range, and that's typically what you would see if you were looking at sonograms of a newborn baby or doing something in that regard. For us, we are using what's called low intensity ultrasound, where it's operating really more almost in the audible range. It's just outside the audible range, about 20 kilohertz. Some groups go up to 100 kilohertz, but
there you go. It can all be edited. We're good. I haven't stopped rolling.
Okay.
So you were saying some groups with the research, they operate at a higher range. You said like 100?
Yeah, depending on the application, our lab really is one of the few, maybe the only lab that's looking at this particular case, where we're looking at trying to heal the tissue at an accelerated pace, or in some cases, heal the tissue at all with this low intensity ultrasound at about 20 kilohertz, somewhere around that range. It's very low intensity, very, very low power or low amplitude that we're delivering to the tissue. So it is very safe technology, and the idea, the future goal or the hope is that we'll eventually be able to, once we've validated that this actually works, we'll be able to move on to in-home portable devices that we could give to patients suffering from open wounds, like diabetic ulcers. Some people get pressure injuries from, maybe they have a spinal cord injury and they have limited mobility. So the idea would be that we can get these into their homes and they'd be able to treat themselves.
Yeah, it seems that the fact that you guys are using ultrasound kind of lends itself to adoption. It seems like ultrasound is something that people are very familiar or at least very comfortable with. There's no kind of, there's this new medical procedure. And like, I think that's kind of sketchy. Ultrasound seems something that's like pretty safe. No one's really concerned about any ill effects or side effects.
Yeah, it has a number of medical applications right now. One group out of Thomas Jefferson University right now is experimenting with using ultrasound to deliver drugs basically through the bloodstream or across the blood-brain barrier it's called microbubbles, but they use these microbubbles and then they basically deliver them on target, and then they zap the tissue with ultrasound and it bursts the bubbles to deliver the drug or the medication. So really cool stuff is going on as far as ultrasound goes, and there's a number of different um, aspects to what's going on with ultrasound. Different frequencies are being used. Yeah, I think you really didn't see ultrasound hit the mainstream in the medicine industry until about maybe the early 90s.
Okay.
That was when it really started coming out. And since then, there's been a lot of development, a lot of studies, on the safety and efficacy of ultrasound. So yeah, it's a relatively safe technology. And you do see a lot more of that kind of surfacing these days. You see a lot more home, even for just cleaning, as a cleaning product. You can use ultrasound to clean precious metals that you couldn't use other kind of cleaning products on. So
Wow. And so do all these different types of applications, do they use relatively the same type of machine, or are they kind of vary depending on what type of frequency you're using, or basically what kind of application you're doing?
right, yeah. So the machines themselves are very highly specialized, and that's the main difference. Imaging ultrasound device would be a very different and much more expensive device than let's say, a portable low intensity ultrasound device that someone is buying over the counter for home use
Right.
in the future. Maybe 10 years from now.
So the imaging ones are more expensive.
Yes,
Yeah.
much more expensive, a much wider range of frequency response, so they can
Okay.
deliver different ranges depending on what tissue they need to image. Bone, things like that have a different image, or a different response to the frequency. So they have to be a little more careful when they're imaging like that.
Right. It's funny because my last year at university, I actually worked on a machine learning project where the idea was that with phones and just other advances in technology, that we'd have more portable ultrasound imaging equipment. The problem is that you still need the technician to interpret the images. And in terms of isolated areas, if you have people living up in like Alaska or Northwest Territories, those people aren't exactly handy or close by. So the
Right.
project I was working on was specifically for hip dysplasia in infants.
Okay.
And what they wanted us to do is basically build an algorithm that could take an ultrasound image of an infant's hip bone and create a mask over the image that identified kind of the bone socket at the top of the femur, the femoral head, and
Mhm.
then basically a line showing on the pelvic bone where it actually fit into the socket. And then based on how far away those maskings were, you could tell whether the infant had hip dysplasia or not. And this is
Right.
to assist someone who's not going through ultrasound training to be able to identify what they're actually looking at.
Right.
So it's interesting. There's kind of the imaging part of it might actually come down in price just because they're trying to, maybe not the equipment, but in terms of like the technicians and the training, might
Right. Right.
eventually, part of it might be replaced with algorithms, at least to assist people looking at it who aren't as trained. I think people get into the idea that either it's AI or a human, but they don't think about, well, you could actually have both. It could be, assisted process, right? So I
Right.
just
Right.
saw, yeah. So I found that's kind of interesting. Um, and I've only really ever known, I think most people don't really think about ultrasound in terms of the imaging aspect. That's because what we're mostly exposed to. I guess if you have some sports background, you might get ultrasound to break down scar tissue and something like that. I guess
Right.
that's that
Yeah.
other part. But I was really surprised and really curious about if we could hear a little more how using, I believe it's diffuse near infrared spectroscopy. I hope I'm saying that right. And then
Yes.
there's another
That's
one.
my baby. Yes.
Yeah, okay. So that's yours. So we'll stick with that. But how does how does that help? It says I saw one of the quick blurbs on the research website that you linked me to quantify the wound healing process. Now, does this mean we don't
Sure.
exactly know how humans' wounds tend to close and heal up by themselves, or we just have cursory knowledge?
We do. a little bit of background on how wounds would heal in this abnormal environment. Let's say you have someone who has diabetes mellitus, or like we discussed before, someone with a spinal cord injury. These wounds typically arise from issues with circulation. So it's a very, very closely related to the vasculature of the tissue. Oftentimes there are other mechanical forces or stresses being placed on the tissue that can induce some of them, especially with pressure injuries. There's something called reperfusion injury, which is a thing that we look at and are currently investigating to see if that's the root cause of these injuries. But the tissue itself, in many cases, won't heal without some kind of intervention by a surgical staff, or potentially this new ultrasound technology to stimulate the tissue. They will be open wounds, and they often will lead to amputation, and in some cases can lead to infection and mortality. So it's a big problem in the United States and around the world. You see a lot of cases per year. So there's kind of this ongoing investigation. It's also a huge financial burden on the hospitals that are caring for these patients, because if a pressure injury or a diabetic ulcer or something opens while that patient is under their care, they look at it as medical negligence, and those hospitals won't get reimbursed for the costs of having to pay for those procedures and that treatment. So it can be billions of dollars a year that are funneled into this, at least in the United States. But getting down to how the ultrasound heals the wound, and how diffuse near-infrared spectroscopy can kind of help predict whether or not that's healing. The ultrasound that we place on the wound is a treatment that we give over about 16 weeks, 15 minutes a week. That's it. Okay. And then we look at patients in the control group, and we look at our patients that are actually getting treatment. It's double blind, so we don't know who's getting treated with the actual device or getting treated with the sham. But we can see with a couple different spectroscopic techniques. One's called diffuse correlation spectroscopy. The other one, which is my thesis, is diffuse near infrared spectroscopy. Both of those help us monitor blood flow underneath the surface of the skin and in different layers of the tissue. So we can see in a typical wound environment, like let's say you get a cut on your arm, and you'll bleed. Your body's natural response is to send kind of an inflammation response to that tissue, and you have blood platelets that start getting sent to that space, and it's supposed to help clot the blood and close up the wound. And under normal circumstances, you would have kind of all these immunological responses and biological responses that are going on to help heal that wound. The issue with someone that has a compromised immune system, and two, a compromised cardiovascular system, is that they do not have, their body doesn't have the ability to produce the kind of the biological or immunological reaction that would typically happen in a healthy individual. Okay. So what happens is these wounds will eventually open up, and then once they're open, they're very difficult to get to close.
Okay, so that was going to be one of my questions, exactly why do some wounds not close? And as you just explained, it could even be that someone maybe just happens to be really ill at the time. Could that also contribute to it? Because you said it's a part of the immune system as well being down. It could not close the wound as much.
Yeah, there's a number of issues with someone that has pre-existing health conditions. One especially with diabetes, you have variations in blood glucose levels, and glucose is one of the building blocks of the human body. It's essential for the function of all sorts of different biological functions. So when you have big swings in glucose, or you have someone who has compromised immune cells or immune system response, which could be any reason, but mostly in diabetics and people with what's called a venous ulcer, which is like DVT, or deep vein thrombosis, can often lead to something like that. Yeah, there's a number of aspects. There's issues with the lymphatic system. I don't know if you're familiar with edema and how that. So basically swollen tissue from the lymphatic system not being able to circulate freely throughout the body.
Okay.
But yeah, all those factors can be compounding or contributing factors to this maladaptive response that leads to the opening and the perpetuation of that
Right.
wound.
And this technology basically, like you said, helps stimulate the part of the body and the blood flow that it needs to actually have the correct response.
We think so.
Okay.
We're currently in the process of verifying that very thing. So what diffuse near infrared spectroscopy allows us to do is monitor blood flow over time. And I guess I should go back. So in a healthy individual, blood flow, oxygenated blood will rush to the wound site and kind of help repair that damaged tissue. In a maladaptive situation, you might have someone with compromised immune system or cardiovasculature. The blood vessels themselves might collapse, something like that. So what diffuse near infrared spectroscopy allows us to do is monitor the blood saturation in the tissue, so both oxygenated hemoglobin and deoxygenated hemoglobin over time. So what that allows us to do is we can see, and we've seen in our preliminary results, we've seen, in the beginning, once these wounds start opening up, you'll see a spike or a peak in blood flow to the tissue, and then it'll eventually taper off and lower down to a normal baseline level. What we think is that there's, by having either surgical intervention for these patients or having ultrasound, these patients are having a more normal biological response to having that wound.
Right. And so I saw you mention diabetic ulcers. Now, I've never
Yes.
even heard of these before, so I'm wondering, what exactly are these? And is there a particular reason you guys are targeting them for your research? Is it just the nature of the wound? It could have the best reaction to this treatment, or is it just the frequency of this throughout kind of the health system that it could potentially, if you could prove that it fixes that, it'll have the best impact on the healthcare system? How does that kind of, what is it and why exactly are you guys targeting it?
Sure. There's a number of reasons. We're looking at both venous ulcers and diabetic ulcers. So far, we've mostly seen venous ulcers and venous ulcer patients, which introduces a whole new set of variables that we kind of have to account for, including edema is a common one. So you might have tissue that is thicker or is hardened or something compared to a more healthy tissue. So we have to factor that in. Diabetic ulcers form essentially because of a lack of blood flow to the tissue. So you might have the tissue itself just not getting the proper nutrients that it needs based on a lack of circulation, and the cell walls, the endothelial cells that line the blood vessels, they'll break down, they'll start to burst, and eventually maybe you might have other layers of tissue, adipose tissue, and superficial tissue like your dermis and things like that start to break down. So that basically that's how they form. And as far as we know, so it's still very much in its infancy as far as
Right.
how the biological function and how these things are forming. But so far, what we think is based on a lack of nutrients going to the tissue. We do know that albumin, which is basically like a cell adhesion molecule,
Okay.
when it's in high presence inside the body, people are a lot less susceptible to injuries. And people that have albumin deficiencies end up, having wounds that don't heal. So typically, the ones that don't heal properly or are maladaptive have lower albumin levels. I'm not a dietitian or a nutritionist, so
Yeah.
but they certainly know what's going on, and in these clinics and in these treatment centers, they certainly know how to provide for the proper nutrition of the patients and make sure that they're getting the proper levels that they need.
Right. And so for the types of tissue that maybe these injuries are kind of showing up, is there just a specific area or type of tissue in the body that you guys are looking at? Or because I'm trying to think right now, I mean, maybe it's just the semantics I'm playing on, but I'm mostly just hearing tissue. I mean, could this be potentially eventually used to regenerate and heal, brain tissue or some other areas of the body that we usually find a hard time getting back?
Yeah. I'm hesitant to cite some work that was done in the 90s, but I'll go ahead anyway. There's a man, I believe his first name was Dr. Walter Hammermill, and Charles Penrose, who's a leading physicist in the world, a theoretical physicist and cosmologist. They led a few studies looking at the brain and what is basically the building blocks of consciousness. And in that study, they did some preliminary research into ultrasound and its effects on microtubules, which make up pretty much every cell in our body. Eukaryotic cells all have microtubules that hold it together as part of the cytoskeleton. So there are studies out there. We don't really know at this point if they're valid, but there have been studies done, and those are actually in the frequency range more of like the imaging ultrasound.
Oh, okay.
And UPenn, University of Pennsylvania, is also doing a study looking into treating clinical depression with low intensity ultrasound as well. And so, yeah, there's a lot of research out there looking into other aspects of where it could be clinically relevant. But yeah, right now I think my group will stick to wounds and just the underlying tissues. One of the main things for me that that I will be looking at over the next year or two now is it's not a very appealing thing to talk about, but calluses.
Okay.
So with diabetic wounds, those ulcers form under a callus. And one of the imaging issues is that no one at presently knows how the callus tissue will interact with the optical imaging systems that we're using. So we're planning an investigation into that over the next year or two, and hopefully we'll find some information leading to how to either look underneath those or look at the actual callus itself and see how it contributes as a factor to the development of these wounds.
Right. So if your guys' research were to go ahead and you found some really promising results, let's fast forward even more and it works. How exactly would you translate that into the industry? I mean, do they have to build a whole different type of machine? Do they just need some new training on how to apply current machines out there? Like, how exactly what's different about the process that you guys do in the lab compared to what they would actually have to do, what they're currently doing now in the
so
industry?
Currently there's no device out there on the market that that is capable of delivering the low intensity ultrasound to a tissue that's kind of commercially available to a client or a patient. So that the long-term goal, at least in the ultrasound studies, is to make these portable devices that are battery powered. And even the ones that we use in our study in the lab today are portable battery powered devices, about maybe that big around. And they just have like a little, it's almost like a wind up toy when you were a kid. And really they have a self timer. You just wind it up, and it has a self timer on the device itself that automatically sets it to a 15-minute window. These are experimental devices, obviously. So if they went out into the market, they'd be packaged and a little more user friendly and nicer. But that's the goal for that study. As far as diffuse near infrared spectroscopy, those imaging devices would be probably more in a clinical setting for rapid diagnosis. So the ultrasound device, I should say, is more of a therapeutic device. You're using that as a therapy for the patient. Diffuse near infrared spectroscopy and diffuse correlation spectroscopy, both those devices would be used more in a diagnostic setting. One study I'm working on right now is with the Department of Defense, the U.S. Army, and Congress to help develop a device, which is we already have one out on the market today with a company named Infrascanner, or Infrascan Incorporated, but the name of the device is the Infrascanner 2000. So if you want to look into that, you can. But that is basically a handheld diffuse near infrared spectroscopy device that allows you to scan the brain or the human head in a combat setting. So if you have someone with a brain injury, traumatic brain injury, maybe they hit their head or some kind of impact to the head, and you want to determine whether or not they have either a traumatic brain injury or a hematoma, and those overlap a lot. But you can use this device to determine whether or not there's additional or excess blood pooling or saturation inside the skull. So there are plenty of studies out there that are looking at how this could be developed into multiple different facets of the medical community. And hopefully we'll have something on the diffuse near infrared spectroscopy device soon. So
yeah, it's funny when you say you're working with the military, and I remember when we met when I was down in Philly, and the American Air Force Association was there at the conference, the Neuroergonomics conference, and here in Canada we don't have as much, I don't want to say militaristic culture. We're not as patriotic as you guys, and I guess patriotism kind of lends itself to military, has close ties to kind of that. But I think people forget just how much of a hand the military plays in advancing, technology in various aspects, and they help a lot in terms of, getting something to have an application right away, or really having the budget basically to push some of these things forward. So it's funny when I hear you working with the military, I'm like, oh man, I forgot, like these guys are, never mind what's in the lab, but in the military, they're like thinking way, way, way ahead.
Right. Yeah. It's interesting. Especially here in the United States, I think there are mixed feelings about military spending, defense budgets, and you see a $800 billion defense bill, and you think, oh man, what, where is this all going? But I think when I started branching out and started working in the healthcare industry, I started to understand where a lot of that defense budget financing is going. I mean, really what it leads to is innovation. It's going to companies to build and engineer and develop new technologies that can save lives. It can also develop new technologies that do the opposite. But I think there's a balance, and there's kind of a give and take in a lot of ways. And we do see a lot of financing from military and government involvement here in the United States. The NIH, the National Institutes of Health, has been critical for this 7-year study that we've been doing, and we've very much been working closely with them. They're funding that operation for us. So yeah, we're very grateful for everyone that's helping us do this, and for the innovation and hopefully the technology that will make it into just the common person's hands in the next 10 or 15 years.
Nice. I always like to ask, when I'm thinking about, when I think of biomedical engineering, I often find that the kind of, say junctions that you're doing research in are very cross-disciplinary. And I'm always wondering, when you're working on a new kind of piece of technology or a science that kind of takes aspects from different foundations of science, is there always one piece, one area that seems to be lacking behind all the others in terms of advancement that might hold back the overall progression? So like material science or something like that. I always kind of like to ask that, to see if there's something that's kind of holding back the progress of the innovation because one area takes longer to develop than the others.
That's a really good question. It's hard to pinpoint. In biomedical engineering is so closely related to public health, and the concern is, well, let's go back to, let's say, World War II, and
Sure.
around that time period, World War II was an immense advancement period of in biomedical engineering and medicine, and one of the reasons for such a vast level of innovation was that there was very little regulation.
Right.
One of the things that really, I would say one of the things that really holds up innovation with respect to biomedical engineering is just the process itself. And it's a very necessary process. You need to be making decisions ethically. You need to be performing these procedures or operations or even studies, clinical research. You need to be doing it in a way that actually benefits the patients and the people that are participating in the studies, and that benefits everyone as a whole, without causing harm to the patients or any of the participants. So there is that. There's an element of needing to get IRB approval. Institutional Review Board is what that stands for. All the paperwork and filing, and the annual reports. There's a lot of paperwork, a lot of bureaucratic process that goes into each of these studies. So I'd say that the interdisciplinary approach to things somewhat advances the innovation more quickly, but the regulation that's involved with that interdisciplinary approach can often be tedious,
Right.
Especially when you're working with a mechanical or material engineering lab that has no biomedical application, but you need a biomedical application from a materials lab. And and a lot of that's done in-house. A lot of biomedical engineering programs and schools have material engineering that's specifically for biomedical engineering or bioengineering. But you might have someone that reaches out to a specialized company or a chemical manufacturer that, once they're involved, then you have to see how it's going to change the innovation process and
Right.
the type of paperwork that's going to be required.
So in terms of you're saying that it's more the process of doing these studies, experiments, and operations that hold up the rate of innovation for obviously good reasons, like you said.
Right.
Do you think there's, off the top of your head, do you see areas of improvement where it could still be probably accelerated, but without taking away some of the rigor?
Well, you and I have talked in the past about machine learning and artificial intelligence, and I think in the process of maybe the next decade or the next 2 decades, we've started, even the FDA has started classifying, software as a medical device now.
Yeah.
And those softwares have just exploded. It really has taken off. I mean, you can have a medical grade device delivered to your cell phone in the form of an application that you can install, that will give you your pulse ox or your oxygen saturation levels, can determine heart rate, respiratory rate, you name it. So
Yeah.
I think we're going in the right direction. There are concerns in the biomedical community, as I'm sure you're aware, of what we do with all this data once it's out there.
Yeah.
Especially in the case of something like machine learning and artificial intelligence, where you're collecting or pooling patient data and then having an artificially intelligent computer make decisions or determinations, potentially for the diagnostics, as a way to diagnose or treat diseases, but also maybe to perform surgeries or operations. A lot of the operations that are going on, especially in cardiac surgery, are done remotely, really, by cardiac surgeons that might be in a completely different location in the world, than the actual surgical suite. But they're done with robotic arms that can go in and do those minimally invasive surgeries. So I think the forefront of innovation that we see today is going to be looking into ethically and responsibly implementing artificially intelligent softwares, and algorithms and machine learning programs that can help us do our job and not necessarily do our job for us, but that can help us or help ease the stress on some of these clinicians or these practitioners as well. So I would say that that's probably the direction we're going.
Yeah, absolutely. I'm trying to think now, like when you say people doing surgeries with robots, I believe it's called the Da Vinci surgical robot. That's the only one I know of. I remember watching, I think, a documentary that touched on it, but I think it's several years old now, but I mean the skill or hours required to get proficient in it were really high. But I think
Right.
yeah, but as these things progress, it'll probably become easier to take a surgeon without taking too much time out of their day doing their regular practice to be proficient with these other tools. And then
Right.
all of a sudden, like you said, it's really interesting that these surgeons are actually not even in the same locale as where the surgery is actually being performed, and effectively you've just like increased the value function of a single surgeon almost tenfold to be able to work in all these other remote locations.
Oh yeah, absolutely. Yeah, 'cause a lot of times you have surgeons that specialize in a very specific procedure, especially cardiac, surgeons and thoracic surgeons have very specific procedures that they develop over time. Um, some of them might know certain procedures better than others. And in a general sense, they're all going to know, the typical procedures, but you might have a complication or something that, you need a specific surgeon to do that surgery or perform that surgery. And yes, that surgeon can be in Germany and perform that surgery in Canada. So that's really nice. It's a huge step in the right direction for us, as far as being able to provide care to people that need it all over the world, especially in developing countries. You see that surgeries that are extremely needed and necessary for some people to survive are being able, are performed remotely and in a relatively efficient amount of time.
Yeah, I'm wondering if once we get to that point where remote remotely performed surgery is becoming more commonplace, how regulation is going to have to change in order to, who's allowed to remotely operate in which country, and how do you, who has the even the responsibility. Like if something goes wrong, who's held responsible? Is it, could you make an argument that's the robot's fault and the manufacturer and they get sued, or is it the surgeon? Like there's so much regulation questions, and it's always tough
Yeah.
when you realize that's going to be a problem, because historically, governmental administrative bodies move a lot slower and react a lot slower to these changes that technology brings about.
Yeah, it's a huge concern. And again, back to AI and machine learning as well. I mean, the more and more we program devices to start making decisions on their own, um, do we know that those decisions are being made in the best interest of the patient or the clinician? Or so there are a lot of concerns, especially when you're doing, I'll say, interstate or intercountry surgical procedures, or even consultations. Who
Yeah.
you have, someone advising another surgeon, maybe from another country, and maybe that causes that surgeon or that technician to make a decision that they wouldn't have otherwise made. So there are a lot of questions, the way that, especially with the current state of technology, how that will play into our future going forward as a society, and the legal implications, and regulatory authorities that really need to dive into that and look at that.
Yeah. I'm wondering, I've been more and more getting into, people call it biohacking, and
Hmm.
really looking at as much biometrics as I can for my body and trying to, min max and optimize things. And I'm wondering, if do you see a lot of biomedical engineers, so-called being biohackers, being real into all the new kind of biometric feedback toys that are out there now for consumers?
I think you do. I think you see a lot of biomedical engineers that we love our toys.
Yeah.
Me, not so much. I try to keep it simple. Maybe I have a fitness watch or something like that. But
Yeah.
I have a number of people that I know that and most of them are proponents for what they call personalized medicine. I think maybe at the conference we discussed that a little bit.
Yeah,
Um,
probably.
but basically, personalized medicine would be, instead of procedures and certain diagnoses being suggested to you based on you having symptoms that match a certain number of criteria, um, they would look at you holistically and
Hmm.
treat you as an individual, looking at your biometrics, looking at your telemetrics, and maybe they're looking at the way that you walk, or the certain things of your posture, or
Yeah.
there's a lot of data that's being collected, and is hopefully in the future going to be useful in allowing people to kind of have their own biohacking um, abilities without
Yeah.
having a whole lot of know-how on how to look at all this stuff and doing a bunch of research. I mean, you and I, that's one thing, but um, is someone who's a lawyer might not want to spend their time.
Yeah, 100%.
uh, right. So, yeah, I think the technology is coming along. I think we'll be there. Maybe in the next 10 or 15 years, maybe 20 years, if
Hmm.
we're being conservative. So, yeah, I think I see a lot of biomedical engineers that like the toys and that really enjoy looking into that stuff. Personally, I try to just keep it minimal.
There's definitely an overload, especially if like you're pretty good at getting 7 to 8 hours of sleep. Like I'm not
Yeah.
really into the ones that track sleep.
Hmm.
But there's certain, even just knowing, I think for me is just knowing exactly how many calories I'm actually burning. Something simple like that is
Yeah.
really nice, but trying to get it in a very trying to use a device that's very non-invasive. So like I know there's this one called the Aura Ring, which is like a new one. It's really expensive. It's like $300, but it's
Okay.
mainly for
Wow.
sleep. But I mean, I would love that because I'm a watch guy. I like to wear watches. So I'm not really big on the Fitbits. I'm not gonna wear like a heart monitor strapped to my chest all day, every day. But
Right.
if we could get something like, I don't know, even like an earring or like a ring, like I'd be all over that. That would be really
Yeah.
sweet.
Yeah, I totally agree. And I don't know if you and I basically met at an event where it was called the Neuroergonomics Conference, and
Yeah.
we're looking at the leading edge of technology as far as interfacing the human body with technology, which was a phenomenal conference. It was a great experience, but it was also kind of eye-opening what is really out there,
Yeah.
and what kind of innovation is kind of coming down the way. Yeah, so watches, I like watches. I'm more of a watch person. Ring, that I'm going to have to look into this because that would be huge.
Yeah, I'll send you the link. It's
Yeah.
pretty cool.
Okay.
Tomorrow I'm actually doing another interview with, have you ever heard of the organization Neurotech X? They're out of
No.
Montreal. So basically,
Okay.
they're an organization where their whole thing is to spread the knowledge of neurotechnology and BCIs, and then basically help spread the skills and train people. So they have city chapters, they have student clubs, meetups. They're kind of like an IEEE, but
Okay.
specifically for neurotech, like the same kind of
Wow.
thing. And so they started in Montreal. They have like thousands of members now, city chapters all over the world. And I helped found the club, the student club for my university, University of Alberta. It would have been a
Hmm.
year ago. So that's how I got introduced to them. But the CEO is coming on my podcast tomorrow. So we're going to get a nice update of all the crazy stuff that's going on in that kind of vein of engineering with the neurotech
Wow.
stuff. So that's going to
I
be
look forward to
exciting.
hearing
Yeah,
hearing
so
that.
that'll be nice to get an update on the whole neuroergonomics and all that jazz that's probably going down.
Yeah. Yeah, it's a huge field right now. Yeah, there's all kinds of, we have a number of labs that are looking at pilot. I think we had some people present at that conference 2 years ago, looking at pilot attentiveness and task-oriented
Right.
environments. And it's just a huge amount of there's a huge amount of studies, data,
Yeah.
and technology coming out. So it's a really exciting time to be alive and be able to see all this stuff coming out.
Oh yeah. Awesome. Well, Ian, we'll get into the last segment here where I
Sure.
got a couple of these polls that I do on my Instagram, and I will just pose a couple of the recent questions to you. And you can kind of give your take. Actually, I'll start from the beginning here. So, would you rather have advanced VR equipment or advanced smart clothes?
Ooh, that's a good question. I guess it would come down to how smart are the clothes.
Think as sci-fi as you want.
Okay. I think maybe advanced smart clothes. It'd be really interesting to see something that could help equalize and regulate body temperature. I
Okay.
think that would be a cool thing. So, yeah, maybe something like that.
Awesome. Well, you are in the majority. 74% said advanced smart clothes, whereas
Okay.
only 26 were VR. So you're in the majority there.
Okay.
All right, next one here. Would you consider introducing lab cultured meat into your diet, lab grown meat?
I am a vegetarian, so
Oh,
this
that's
is a
right.
very difficult question for me to answer.
It might actually be a perfect question for someone like you.
It's yeah. So because it's a whole new area of ethics that we haven't
Yeah.
that we really haven't looked into. Personally, I just started experimenting with meat substitutes.
Okay.
So seitan is one that's made from wheat gluten. If you don't have celiac disease, it's a great protein source. So yeah, I don't know. I think I'd probably still go the meat substitute route. I don't know about lab grown meat for
Okay.
myself personally.
Okay. Surprisingly, the outcome of this one was actually pretty positive. 71% said they would try it.
Would
So
they?
I was,
Okay.
yeah, I was pretty surprised because I think when people say lab grown meat, they think of something synthetically concocted up. They don't
Right,
realize
right,
it's like taking a cell and basically just multiplying a meat cell over like a
right.
scaffolding. So actually, my first guest I had on this podcast, I think it was maybe episode 3. A good friend of mine, Chris, he works at a um, cellular agriculture startup right now, and they're doing lab grown meat. And they basically make the cultured solution and then they sell it to companies to actually make the meat products.
Oh
So
wow.
we had a
Okay.
good, yeah, if it's something you're interested in, I have an episode where he kind of goes in on how exactly it works and where things are at.
Yeah, I
So
would love to check that out. Yeah,
yeah,
I'm really curious because I wonder how a lot of what gives meat its texture and flavor is the animal living and
yeah,
the exercise that's involved and
yes, that's
the
right.
stretching so I wonder, I guess I'm very curious to learn how whether or not they're going to exercise the meat and how that's going to work in the lab
Right.
environment.
Well, one of the challenge she did say was that, yeah, like there's no real, the ligaments and little bits of fat and stuff in the meat is what part
Hmm.
of gives it its texture and its flavor sometimes. So being able to replicate that is a challenge. So
Yeah,
that's
yeah.
something they're working on. But it's cool that their whole thing is the point of his startup is to make the process cheaper. So they've actually found a cheaper way of making the solution. So you don't
Wow.
have a $1,200 chicken nugget, basically.
Right, yeah, that's great.
Okay, so let's get to the next one here. Would you be interested in neural enhancements, something like even Neuralink's N1 chip implant?
Ooh, that's a tough question. um I think my inclination would be to say no.
Okay.
uh yeah, I don't know.
What about
It
why?
depends.
What about by way of something like a nootropic?
Potentially.
Okay.
Potentially, yeah. I don't know. I'm very natural, very much a advocate for natural living. So I don't know.
Ian's smart enough, everyone. Here we go.
So yeah, it's hard to say now if it. I think if it could lead to there's actually been a lot of work in this field with pharmaceuticals, at least intensifying or increasing cognitive ability. If you look at, I think, what was the name of? I think it was originally called Provigil, and the second one that came out was called New Vigil. And these were two pharmaceuticals that were, I believe, originally designed for people with work shift disorder, people that had problems sleeping and narcolepsy and things like that. But they found that it is very useful at increasing productivity and cognitive ability. Um, so yeah, it would be interesting, I think, to see what the side effects of the nootropic lifestyle would look like, and
Yeah.
if there are any downsides and what trade-offs would be there. As I would also be interested in looking at neural chips and neural link as
Yeah.
well,
Yeah.
and what the pitfalls, side effects, and potential downsides could be there.
Yeah, that's going to be interesting. I did take a nootropic. Um, it was last summer. I got the one from Onnit, which
Hmm.
was about working memory vocabulary, which is what they did their double-blind placebo study out of. I think it was the Boston Center for Memory or something like that. They did the study out of. Um, But yeah, and I enjoyed it. I felt sharper. I don't know how much of it was placebo. It would have
Right.
been nice to do it for 60 days until the 30 days. I think even the study you saw the max effects right at 30 days. So as I've been reading more, getting back into kind of neuro stuff. I have my eyes on another company called HVMN by Jeffrey
Oh,
Wu. Actually started them. I don't know if you've heard of them,
okay.
but he was actually, I think, one of the he actually made his own nootropic in his like kitchen way back when, and he's like the most famous like biohacker. So he has this whole
Yeah.
company now that has all these nootropics and MCT oil and all this stuff. So
Hmm.
I want to give theirs a go. They actually have two different nootropics. One's for, I think, like focus and energy, and then another one specifically for memory, which is interesting. So
Okay.
yeah,
Yeah, I'll have to look into this a little more. I've seen more nootropics coming onto the market more
yeah,
and more lately, and it's hard to know whether certain ones are valid or viable, or
yeah.
they don't go through the same regulatory procedures that you would normally see in the pharmaceutical industry. But there are certainly valuable, fitness uh, supplements out there that I like personally. So I
Nice.
I definitely I could see myself taking nootropics potentially. Yeah.
Okay, cool. I got a bunch of links coming your way after this then.
Cool. Cool.
Okay, next question here. Are you excited for foldable devices, bendable tech? This has become kind of a little bit of a phenomenon with folding phones and whatnot.
So the audio cut out a little
Oh,
bit.
okay.
That was
Um, are you looking forward or excited at all for foldable devices? I know there's foldable phones coming out. Really, I like to call it soft tech.
I am. Yes, I have been looking at the new Motorola. I think it's a Razor that I think was the first real hard release, or at least open market release of the foldable flip phone.
Oh,
Um, so I don't know if you've seen that, but the screen folds in half. Um,
interesting.
yeah. So is that what you said? Foldable or
Yeah, absolutely.
foldable? Okay.
Yeah,
Yeah. So they have a phone. It's about I think $1,400 right now, and
naturally, yeah.
if you want to wait for the price to come down, you certainly could. But it's it looks like an interesting piece of tech. I think foldable devices would be amazing. I think foldable screens, particularly even in the medical setting, would make things incredibly easier.
Ah,
Um, if you think about imaging technology and all the screens that you need, and the portability aspect of moving in an ultrasound device, or if you have an x-ray machine and wanting to look at those images, if you can if you could have a foldable device that's easily portable, that you could take the radiologist, or the maybe even the surgeon that wants to inspect those elements, I think that would be really useful.
yeah, absolutely. I think
Yeah.
it's more about what does what does soft tech, what does bendable tech get us, not just like folding a phone. I think that's kind of what's
Right.
most exciting
Yeah.
about it, like you said, with the medical applications. But
Yeah.
yeah, I'll go back to the results. So for the neural enhancement, 60% of people said they would be interested in neural enhancement, which I was pretty
Okay.
surprised. People are surprising me. Um, the foldable devices hype was actually 50-50. So there is
Was it?
a
Okay.
split decision on that one so far. And our last question, our most recent poll. This one's not, I guess, it could be that divisive, but would you be interested in driving an electric car?
Yeah. Yes, absolutely. I'm I've never driven a Tesla, but I would love to drive one sometime.
Yeah.
And I think the electric car could be, if we can get the battery size and quantity
Yeah.
down to a reasonable level, and get them into a really efficient um, vehicle that can do more than 200-300 miles, I think I would definitely buy one. Not even that so much as just having more charging stations available and having fast charging options where you could turbocharge for 45 minutes and then get another
that's a big thing for me too. And I think people, there's kind of this thing, if you were to say no, some people, there's a group of people or a certain ideology that gets mad at you, like, oh, what do you mean electric's the future? But a good thing you mentioned is some places like Alberta don't have the infrastructure necessary for electric cars to be so widespread. We don't have enough charging stations. Like, I'm moving to Toronto, and I'm looking at maybe I can get a Tesla in a couple of years, but I'm probably not going to be able to have a parking stall in my apartment building that's going to be able to charge my car. So it's not even feasible, right?
Yeah.
So.
Yeah, that said, I drive a diesel right now. And I mean, one of the things I really like about diesel is just the level of efficiency. I mean, I get 50, 60 miles to the gallon on average, and my tank, with a full tank, I get about 900 miles of range. So those are the trade-offs I think we will see hopefully being addressed in the future, in the next few years, for electric cars. Just getting that level of efficiency out of the vehicle, that it can actually do a 600 to 900 mile road trip and without charging.
I think Tesla has done its job in terms of making people realize it's a viable option. I think the best thing for them now is they need competition. They need Rivian, they need Lucid, they need these other electric car startups to start getting going and helping them push the envelope. Because it's
Karma, I think, came out with an electric car recently.
Oh, really?
That supposedly is pretty competitive against the Model S, but I'll have to look into that a little more.
I know Ford has done a couple. An electric Mustang, I believe. They announced a few months ago.
Wasn't aware.
And people were really hyped about that. And I think they're working on an electric F-150, which I know a lot of people are excited about. So
that would be impressive.
Yeah, absolutely. Yeah. I know a lot of people are excited about the Cybertruck, so I think Ford's thinking, oh, maybe we should dip our toes into this. So
yeah, absolutely.
Awesome. So that poll actually was 94% said yes. I think there was only actually 2 people that said no, but given people live in different areas, have different circumstances. So that's all the polls. Ian, thanks for hopping on. It was good to see you. Good to talk to you again. It's been a while, almost 2 years, like we said.
Yeah, it's been a long.
Appreciate, giving us the rundown, the exciting stuff you're working on. And if you come up with some exciting news or any other stuff that you'd want to come on and talk about, just let me know. I'd be happy to have you.
Absolutely. Yeah, it's been a pleasure, Brandon. Thanks so much for having me. And it was great hanging out with you for a little bit. And anytime.
Awesome.
Love to join you again.
Awesome. Well, thanks everyone for tuning in. See ya.